Fluid coding and AI is testing MiMo, where coding agents usually get expensive, inside the repo loop. Xiaomi is claiming long horizon coding strength, huge context, and low API cost. The real question is narrower and more useful. When the task stops looking like a demo, does MiMo use tools economically, keep its plan alive, and recover from bad test output without burning the savings? Here is the claim stack. Xiaomi describes MiMo v2.5 Pro as a 1.02 trillion parameter mixture of experts model with 42 billion active parameters and a 1 million token context window. It is positioned for agentic software engineering and long horizon tasks, and Xiaomi lists it on its API platform under the MiMo v2.5 Pro model tag. That is enough to make it worth testing. It is not enough to trust the agent loop. The pricing is the part that grabs developers first. Xiaomi's overseas pay-as-you-go page lists very low token prices after the May 27, 2026 cut. Cached input is tiny. Cache miss input is still low, and output is under $1 per million tokens. But agent cost is not just price per token. It is calls, retries, repeated file reads, giant logs, broad test runs, and output that says too much before doing too little. Xiaomi's strongest first-party story is not a tiny toy task. The MiMo page describes a sys-y compiler implementation in Rust, 4.3 hours, 672 tool calls, and 233 out of 233 hidden tests passed. The page also says the model recovered after a later refactor regressed 2 risk-free tests. That is an impressive receipt. It is also not a trace we can audit line by line. Third-party context makes the story more balanced. PinchBench shows Xiaomi/MiMo v2.5 Pro with a strong OpenClaw score in its visible table, 89.5% best score, and 87.5% average score. Artificial analysis tracks MiMo v2.5 Pro provider behavior and says supported providers expose function calling in JSON mode. So the model looks competitive. The evidence does not say it is magically efficient in every Repo-Agent setup. MiMo code is the most important context because it separates model ability from agent discipline. Xiaomi's own blog says the model is stateless across API calls, so the runtime owns continuity. Long histories need memory, checkpoints, and retrieval, not just more context. That matches Claw SWE Bench, which argues that harness choice can move coding. Agent pass rates by 27.4 percentage points under fixed models. So the test cannot be just, did it pass? A useful MiMo API run needs a receipt book. Every model call, input tokens, cache tokens, output tokens, provider, timestamp, tool call, shell command, test command, final diff, and final test result. GitHub's token efficiency guidance makes the same point. Token reduction only means something if quality and amount of work do not quietly shrink. The task should be small, real, and mildly hostile. 1 deterministic failing test. Noisy logs, 1 warning that looks scarier than it is. 1 real assertion failure that actually points toward the bug. The fix should require reading existing code, editing 1 to 3 files, and retesting in a narrow loop before running the broader check. That shape forces the model to diagnose, not just autocomplete. Tool economy is the first score. I would count file reads, searches, edits, test runs, and repeated commands. A strong run reads the likely files, avoids blind grep loops, uses targeted tests before a full suite, and does not keep reopening the same context because it forgot what it just saw. If MiMo passes while rereading half the repo, the result is not a clean win. It is strong but wasteful. Plan continuity is the second score. MiMo Code's blog is explicit that the runtime has to maintain state across calls. For a repo agent, that means the plan should survive bad output. The model can revise the plan when evidence changes, but it should not abandon the original goal, chase unrelated warnings, or declare success before the stopping condition is true. This is where cheap context and actual memory strategy separate. The recovery test is simple. Give it bad-looking output with both noise and signal. An environment warning should not hijack the task if the real failure is an assertion. A good run isolates the true failure, patches the smallest responsible code path, retests narrowly, and only then expands verification. Xiaomi's demos describe recovery after regressions. This is where we check whether that behavior shows up in a normal repo trace. Until a local trace exists, the honest verdict is provisional. MiMo v2.5 Pro has serious signals, large-scale agent positioning, low API pricing, strong first-party demos, and independent benchmark visibility. But the Repo-Agent claim only survives if the trace shows disciplined work. The labels I trust are conservative, strong and efficient, strong but wasteful, cheap but brittle, or harness, limited. Past tests by itself is not enough. The practical takeaway is this: MiMo is worth testing if you can capture the full loop, not just the final patch. Log the tokens, count the tools, review repeated reads, separate model behavior from harness behavior, and watch the test closely because a cheap model that thrashes is still an expensive coding process. The question is not whether MiMo can code. The question is whether it can make the agent loop cheaper without making the work thinner. If this kind of trace-level AI coding evaluation helps you cut through benchmark claims, like the video and subscribe to Fluid Coding and AI. The next useful comparison is not the loudest demo, it is the cleanest receipt.